Okay, so again, this is lesson and homework 52, the same worksheet, and the question we are trying to answer here is how is this all connected? So number 1A, find the general solution. The general solution means that you do not have any numbers here. This is an indefinite integral, which means you have to make sure that you're ending it with a plus c. So if you're going to go ahead and integrate, you're going to integrate one at a time. So to integrate 6x to the first, you're going to do 6. Take the x to the 1 higher power divided by that power. Then to integrate the -5, don't forget to add a variable. Then to go ahead and simplify, 6x squared divided by 2, that's 3x squared minus 5x. And then because of the fact that this is the general solution, you want to go ahead and add the plus c. So again, this is actually the first thing we started with back in chapter 4, probably about 2 weeks ago, making sure that you can integrate using the formula sheet, and finding the general solution means you have to end with a plus c. So have to throw it back for a second before we add in the relationship to the new stuff. But any questions so far? Okay, then we took it up a level, and instead of finding the general solution, we found the particular solution. So to find the particular solution, you're going to integrate just like you did in step A, and then you're going to go ahead and actually solve for C. So we can actually start by giving ourselves just a little reminder here. Because of the fact that they're giving you f prime, this is just a reminder that if you want to find regular f, you're going to do the integration of f prime, and then don't forget your dx. So f of x, we already did this integration. It's the same as it was in the previous step. It's 3x squared minus 5x plus c. And then because of the fact that it's a particular solution, you're going to go ahead and actually solve. How do you solve? Well, this ordered pair is always x comma y, or in this case, x f of x. So everywhere there's an f of x, you're going to put a -4. Everywhere there's an x, you're going to put a 0. In terms of finding the particular solution, this is actually an easy one because of all those zeros. This cancels, and you wind up getting that -4 is equal to c, which means your final answer to this problem is a particular solution of 3x squared minus 5x minus 4. So again, not that it's hard, but I just want to clarify and make sure we understand the only difference between the general solution and the particular solution is the fact that you actually solve for c. So again, bit of a throwback to the earlier part of chapter 4. Any questions to there? And just checking, are you guys still with me? Yep. Okay, thank you. All right, so now we're going to reiterate what we did yesterday. Find the area by using the limit definition. So the limit definition, when you see those words, that's how you know that it's that big, long process from yesterday. Remember, I have to tell you what the equation is, and notice that in this case, it's another linear. Then the x-axis, which it will always be, and you're going from 0 to 2. I have to give you all of that information. So the first piece of information I give you, that's the A. The second piece of information I give you, that's the B. So once you have all that information, you're going to start by writing the formula. So we're going to find the limit as n goes to infinity of the sum from 1 to n of b minus a over n times f of b minus n over ni, b minus a over ni, sorry. And again, I just want to reiterate that this is something that does not change. You might have already written it down, it's in your notes, or you can write it down now. Once you write it down now, this doesn't change. This is always going to be your first step. So the limit as n goes to infinity means we're adding up more and more rectangles. You're always going to go from 1 to n of b minus a over n of f of b minus a over ni. Again, this is the right-handed approach. So I'm going to drop my limit statement just for now. I'm going to put it back in at the end, but it's just going to save me a step of not having to write it every single time. So this is now the sum from 1 to n of, if I do b minus a, that's 2 minus 0. So that's how I get 2 over n times f, 2 over n I. I'm doing this not only to do more practice, but also to do it live, because I know yesterday it might have been hard to tune into the entire video. So for anybody who might possibly have a question, now would be the time to ask it. So any issues up to here? Okay. So now the next step is the sum from 1 to n of 2 over n. And now I'm actually going to calculate this f of 2 over ni. So remember what that means. You're going to go to the f function. Everywhere there's an x, you're going to put that expression. So inside of this parentheses, it's a 6 times 2 over ni minus 5. And again, notice that the f is gone. The f is gone once you actually plug that value into the f. Little bit of simplification. So in the next step, this is the sum still from 1 to n of 2 over n. If you multiply 6 times 2 over ni, you're going to get 12 over ni minus 5. Then you're going to distribute. So this is the sum from 1 to n of 24 over n squared I minus 10 over n. Give you a second just in case you're still writing anything down or need to catch up. Questions? Okay, so now I'm going to split this. So I'm going to split this into the sum from 1 to n of 24 over n squared I minus the sum from 1 to n of 10 over n. You're always allowed to split it. Then in the next step, you want to factor out the constants. So the constants from the first value is 24 over n squared. The constant from the second value is the whole thing. So if I factor out 24 over n squared, this is now the sum from 1 to n of I. If I factor out the whole 10 over n, this is now the sum from 1 to n of just 1. Any questions up to here? Okay. The whole reason why you want to do that is because this is a formula and this is a formula. If those don't wind up being formulas, then none of this works. So in the next step, I'm actually applying the formulas, which is why the summations are going to be gone. So 24 over n, that's the constant. And then the sum from 1 to n over I, that's a formula. It's n squared plus n over 2. And remember, it's really n times n plus 1, but I would distribute it just to make it a little bit easier. Minus the constant, which is 10 over n. And then to find what this sum is, remember when you're taking the sum of a constant from 1 to n, you just multiply them to get n. So anything in black, that's a constant. Anything in purple, that is a formula. Yep.
In the last step that you, or the second last step that you did, the 24 over n, shouldn't that be an n squared?
Yes, thank you. So I lost my squared. Thank you.
Okay, thank you.
Anyone else? Okay, so the hard part's over. You're almost done. All you have to do now is simplify and then take the limit. So I'm going to do 24n squared plus 24n. So I distributed the top. And these are each going to be over 2n squared. Minus, cancel the n's, 10. Simplify. So 24n squared over 2n squared, you can cancel the n squareds, and that's going to give you a 12. Plus 24 divided by 2 is 12 over n minus 10. And then in the very last step, you just have to bring back your limit statement. So this is the limit as n goes to infinity. Add the constants, so 12 minus 10, that's a 2, plus 12 over n. When you actually take the limit of a constant is just a constant. The limit as n goes to infinity, if you try to divide 12 by infinity, you're getting such a small number that that's essentially 0, which means your answer to this problem is 2, and that is correct. Remember what that answer represents. It's the area under the curve. Why were we able to find it? Well, because we were adding up a bunch of rectangles, and because we took the limit as n went to infinity, we were adding up more and more and more rectangles, which means we were adding up as many as possible, which means give me the answer. So 2 is the promised land. Anytime you're asked to do this for a linear equation, you're going to have almost an identical set of steps. So again, you really do kind of get into a groove. And then the last thing I want to show you is check your answer to part C. So again, you can always check your answer to these problems by doing the following: finding the definite integral, and then doing the fundamental theorem of calculus. So you're about to be really happy or really annoyed based on this last step. So notice here, we are now a definite integral because of the fact that there's a start and there's an end. So you're going to integrate just like you did previously. So when you integrate 6x, you get 6x squared over 2, which is 3x squared, minus integrate the constant is 5x. And then remember, you draw that vertical line and you put your two bounds in. You're going to start by plugging in the top number. So when I plug in a 2, I'm going to get 2 squared. Well, I'll show you some more steps. So that's 3 times 4 minus 10. That's what happens if you plug in the 2. Then remember, it's always a minus. And then I'm going to plug in the 0. And you're just going to get a 0. If you calculate that, you get 12 minus 10, and it turns out that the answer is 2. And if you're wondering, is that answer always going to be the same as this answer? Well, yeah, that's kind of the whole point. So again, you're either going to think that's really awesome that they wind up being the same, or you're going to think it's really annoying, like, why can't I just do that? The truth is, to really get to the heart of calculus, you do have to be able to do it both ways. But the good news is, from this point forward, any problem that I give you that asks you to use the limit definition, you can always check your answer by just doing step D and then making sure that they're equivalent. So again, I hope it's good news. I hope it's interesting, and I hope it makes sense, the fact that they agree. If you still aren't quite sure why they agree, I could explain it to you a couple more times if you're interested. For now, you kind of just have to know that they do. But questions? Okay, you're not going to do it yet, but if you look at the back, notice that the back is the same exact 4 steps, but this time it's it's a quadratic equation. So the fact that it's a quadratic just means that step C is a little bit messier. You're going to try the back for homework, but I want to go back and finish yesterday's video because that's what's going to help you do that.